I figured, I'm going to show you the solution here, but I figured I'd go ahead and work it out if you need one more explanation. I factored the left side, still greater than 0, listed the zeros, what makes what x values, or what inputs, or what domain values, or what real numbers, however you want to say it. What can you replace x with that would cause the left side to be equal to 0? 5 and negative 3. Okay? So 5 and negative 3, I've broken down my interval into 3 equal parts. To the left of negative 3, we can pick a test value of negative 10. That would cause the first factor to be negative and the second factor to be negative. Two negatives multiplied together give us a positive. And then in between negative 3 and 5, we have 0. 0 minus 5 is negative. 0 plus 3 is positive. So we know that on that interval, the function's values are negative. And then on the interval from 5 to infinity, let's pick 7. 7 minus 5 is positive. 7 plus 3 is positive. And so on that interval, function's values are positive. And what do we want? Well, we have to look back. We want to know when this polynomial is greater than 0, and it's greater than 0 where you see the plus signs. And those intervals, we can say, I'm not going to rewrite the problem this time. On the interval from negative infinity to negative 3, now greater than, so we won't use bracket, and combined with the interval from 5 to infinity. And that's our answer, right there. Okay? Alright. Next one. Last one. Is this one going to be a tricky one? I don't know. X plus 2, x minus 2 over x times x minus 2. When I wrote this problem down, I remember being angry at myself for putting the parentheses there, but I didn't want to rewrite it, so I just left it factored. So I'm just going off the assumption that if I wrote that as x squared minus 2x, that you could factor it like that. And you're probably, I don't know, you're okay with that, I'm sure. X minus 2's can cancel here, therefore x equals 2 would not be a 0. The only 0 of this function would be when x is equal to negative 2. And the d/e, though, of the function, even though we cross out, we still have to leave it there, and we have to include it in our d/e category because of the domain. The domain restrictions would be x can't be 0 and x can't be 2. So those provide us with when the function's values are non-existent. Okay? And then we want to make sure we draw our little sign chart. Okay? So a sign chart would have all 3 of these values. Don't forget, we're going to put all 3 of these guys on there. Negative 2, 0, and 2. And then we're going to test the sign of the function on each of these 4 intervals, 1, 2, 3, 4. So to the left of negative 2, let's choose negative 5. And again, we can use this reduced form of the rational function. So when x is equal to negative 5, we have a negative 5 plus 2, that's a negative, over a negative 5, which is negative as well. So on the interval from negative infinity to negative 2, the function's values are positive. In between negative 2 and 0, we have negative 1. Putting negative 1 in for x, we get a positive x plus 1, or x plus 2. On that interval is positive, and then negative 1, obviously x being negative 1 is negative. So we have a positive divided by a negative on that interval. And then between 0 and 2, we see that we can choose 1. 1 plus 2 over 1, that's positive divided by a positive. Well, that's positive as well. And then when x is positive 3 or greater, or 2 or greater, I should say when x is greater than 2, we have positive divided by a positive again. And so we have that interval right there from 2 to infinity, where the function's values are going to be positive. So again, I got a good one here because we don't have to write a whole lot. All we have to do is see that we want only the x values in which this function is less than or equal to 0. And the one thing I forgot, see the minus signs there, one thing I forgot is to list d/e or equals 0 under each of these guys. So for rational functions, it's more important to do that because for polynomial functions, they're always equal to 0 here on the sign chart. But for the rational functions, we have to be careful not to include endpoints if those endpoints are going to cause our function to not exist. And the 0 would only be at negative 2, but the d/e is at 0 and 2. Okay, so be really, really careful with that. That's where I see students missing a few points to get really frustrated because It just was a parentheses instead of a bracket. So just be careful there. And so our solution would be all the real numbers between -2 and 0, including -2, but not including 0. Okay, be really careful there. I know I've said that, but there you go. I'm going to try to put some multiple choice questions for you to answer on a Google form, so enjoy those, and I will see you in class.